Hello everyone, myself Hanasha. So today we are going to discuss a topic named mean value theorem. So let us start with the Rolle's theorem. So let f be a function that satisfies the following three hypotheses. So the first condition is f is continuous on closed interval AB. The second criteria is f is differentiable on open interval AB. And the last condition is fa is equals to fb. If these three conditions holds true, then there exists a number c in open interval AB such that f dash of c is equals to 0. So firstly you have to verify whether these three conditions holds true or not. If these criteria are satisfied, then we can find the value of c using the condition f dash of c is equals to 0. Now after obtaining the value of c, whatever value you have obtained of c, you have to check whether it belongs to open interval AB or not. Fine. So these are the criteria of Rolle's theorem. So let us understand this using example. So we have to verify Rolle's theorem for f of x is equals to e raised to minus x sin x on closed interval 0 to pi. So let us start verifying the three conditions. So the first condition is this function should be continuous on closed interval 0 to pi. Now we can see that f of x is equals to e raised to minus x sin x, right? So we can say it is continuous on closed interval 0 to pi because it contains exponential and trigonometric function, right? So we can say it is continuous. Now second, we can check that whether the derivative of this function exists or not. So let us find f dash of x. So I have to apply u into v rule. So e raised to minus x as it is, derivative of sine will be cos plus sin x as it is, derivative of e raised to minus x will be minus e raised to minus x. So we can see that f dash of x exists on open interval 0 to pi. Now the third condition is we have to verify fa is equals to fb. That is, in this example we have to check whether f of 0 is equals to f of pi. So let us check f of 0 answer. So if I put 0 in place of x, here I will get e raised to 0. So answer is 1 and sin 0 is 0. So answer will be 0. And our value of f of pi will be, if I put over here sin pi, we know the value of sin pi is also what? 0. So we can say that f of 0 is equals to what? F of pi. So all the three conditions are verified. Therefore, we can say that we can apply Rolle's theorem, right? So now we have to find the value of c. F dash of c is equals to 0. So we have the derivative, right? In place of x you have to put c. So we will get e raised to minus c cos c, right? Plus minus minus. So minus e raised to minus c sin c is equals to 0. Fine. So now we can take out e raised to minus c common. So cos c minus sin c is equals to 0. So from this we can say that this cos c minus sin c is equals to 0. Why? Because this exponential function can never be 0. Okay, so since e raised to minus e is not equal to 0. So from this we can see that cos c is equals to sin c. So what we can write? Tan c is equals to 1 because sin upon cos c is 1. Therefore our value of c is what? Pi by 4, which belongs to open interval 0 to pi. You can see. Therefore we have verified our Rolle's theorem. Okay. So now let's go to our next example. It is given that Rolle's theorem holds good for the function f of x is equals to x cube plus ax square plus bx, where x belongs from 1 to 2. At the point x is equals to 4 by 3, we have to find the values of A and B. So now here we are already given that Rolle's theorem holds good, right? So we can write that our function f of x is continuous on closed interval 1 to 2. Next, let us find our f dash x. So that will be 3x square plus 2ax plus b, right? This exists on open interval 1 to 2. Next, what we have to write? F of 1 is equals to f of 2. Now put 1 in place of x. So you will get 1 plus a plus b is equals to, put 2 now in place of x. So 8 plus 4a plus 2b. Now simplify this. So we will get 3a plus b is equals to minus 7. Fine. So this is our first equation. Now next we are given the point C also. So now what we will do? Write f dash of 4 by 3 is equals to 0. So now in this derivative you have to put 4 by 3 in place of x. So you will get 3 into 4 by 3 whole square plus 2a into 4 by 3 plus b is equals to 0. So now we again obtain one equation in form of a and b. So you can see 1, 3 will get cancelled out. So what will remain? 16 by 3 plus 8a by 3 plus b is equals to 0. Now if I simplify this by taking LCM, what we will get? 8a plus 3b is equals to minus 16. So this is our equation 2. Now in order to obtain the values of a and b, let us write both the equations once again. So 8a plus 3b is equals to minus 16 and 3a plus b is equals to minus 7. Now to apply elimination method, multiply this by 3. So what we will get? 8a plus 3b is equals to minus 16 and here we will get 9a minus plus 3b is equals to minus 21. Okay. So now put minus sign and here plus sign. So we will get minus a. These two will get cancelled out is equals to 5, right? So our final answer of A is what? Minus 5. So let us put this answer in our equation 1. So 3 into minus 5 plus b is equals to minus 7. Right? So b will be minus 7 plus 15. So our value of b will be what? 8. Okay, so these are our values of A and B. So now let us go to our next theorem, that is Lagrange mean value theorem. So now let f be a function that satisfies the following three hypotheses. So the first condition is f should be continuous on closed interval AB. Next, f should be differentiable on open interval AB. These conditions are same as our Rolle's theorem. Now, there exists a number c in open interval AB such that f dash of c is equals to f of b minus f of a upon b minus a. Again, using this, you have to find the value of c and check whether it belongs to open interval AB or not. So let us understand this using one example. So we have to verify Lagrange mean value theorem for the function f of x is equals to square root x square minus x in the interval 1 to 4, closed interval 1 to 4. So our f of x is equals to square root x square minus x is continuous, right, on closed interval 1 to 4. Why? Because it is a polynomial function, right? Now second, let us find its derivative f dash of x. So this can be written as what? X square minus x raised to half. Okay? And also we know that the derivative of root x will be what? 1 upon 2 root x. So it will be 1 upon 2 square root x square minus x. Now applying chain rule. Again do the derivative of this. So it will be what? 2x minus 1. So this exists on open interval 1 to 4. So both the criteria are satisfied. So the third condition is there exists a number c such that f dash of c is equals to what? fb minus f of a upon b minus a. So f dash of c. So in this we have to put c in place of x. So we will get 1 upon 2 root c square minus c, and in the numerator 2c minus 1 is equals to f of b. So our b is 4 is equals to f of 4 minus f of 1 upon 4 minus 1, right? So now simplify this. So we will get our answer as 1 upon 2 2c minus 1 upon square root of c square minus c is equals to f of 4. So here you have to put 4 in place of x. So what you will get? 16 minus, if I put 4, it will be, answer will be square root 12, right? Minus. Now if I put 1, then the answer will be what? 0. You can see 1 minus 1, so answer is 0. Upon, we are getting what? 3. Okay. So now 1 upon 2, this can be further written as 2 root 3 upon 3. Okay, so now let us cross multiply this. So we will get 6c minus 3, okay, is equals to 4 into 3c square minus 3c. This can be multiplied as 3c square minus 3c. So now let us square on both the sides. So we will get 6c minus 3 whole square is equals to 16 into 3c square minus 3c. So now let us open this bracket. So we will get 36c square minus 2ab. So 2 into 6 into 3. So minus 36c plus 9 is equals to 48c square minus 58c. Right? So now let us simplify by taking these two on this side. 12c square minus 12c, and also this, so minus 9 is equals to 0. So now we take out 3 common, so we will get 3 times 4c square minus 4c minus 3 is equals to 0. So now we can factorize this, right? So we can factorize as 6 and 2. So 4c square minus 4c plus 2c minus 3 is equals to 0. So the here we'll get 2c common, so 2c into 2c minus 3 plus 1 into 2c minus 3 is equals to 0. So our values of c are minus half and c is equals to 3 by 2. Now you can see that this c is equals to minus half does not belong to 1 to 4. Therefore, only possible value of c is 3 by 2, which belongs to 1, 4. Okay, so this is our answer of C, and hence the Lagrange mean value theorem is satisfied. Okay, so now let us go to the next example. Now we have to find the value of C using Lagrange mean value theorem if f of x is equals to x square minus 3x minus 1, where our x belongs to minus 11 by 7 to 13 by 7. So now first criteria is satisfied because it is a polynomial. So we can say that f of x is continuous on closed interval minus 11 by 7 to 13 by 7. Second, let us find the derivative of f of x, which will be 2x minus 3. So this exists on open interval minus 11 by 7 to 13 by 7. Now let us find the value of c using our condition f dash of c is equals to f of b minus f of a upon b minus a. So here our b is 13 by 7. So f of 13 by 7 minus f of minus 11 by 7 upon 13 by 7 minus minus 11 by 7. So let us put the in place of xc in this. So we will get 2c minus 3 is equals to Now, in place of x, you have to put 13 by 7. So, I will get 169 upon 49, right? Minus 3 into 13. So, 39 by 7 minus 1. Minus, now if I put minus 11 by 7, I will get 121 upon 49, right? Now here minus minus plus. So plus 33 by 7 and minus 1 upon 24 by 7. Okay. So now let us solve this further. So our total answer will be 2c minus 3 is equals to. Now 169 minus 121 is equals to what? 48 by 49, right? Now next, minus 39 by 7 minus 33 by 7. So our answer will be minus 72 by 7, and this minus 1 and plus 1 will get cancelled out. So upon 24 by 7. So therefore 2c minus 3 is equals to, now I have to multiply this by 7. So 48 minus will be 48 minus 504, right? And upon 49 upon 24 by 7. So 1 7 gets cancelled out from here. So on simplifying, this will be minus 19 by 7. So now take this plus 3 on this side. So 2c is equals to minus 19 by 7 plus 3. So 2c is equals to minus 19 plus 21. So 2 by 7. So the value of c is what? 1 upon 7, which belongs to our open interval minus 11 by 7 to 13 by 7. So this is the value of c. Okay. So now let us go to our next theorem, that is Cauchy's mean value theorem. So suppose that function f and g are both continuous on closed interval AB and differentiable on open interval AB, and g dash of x not equal to 0 for all x in open interval AB, then there exists a number c in open interval AB such that f dash of c upon g dash of c is equals to f of b minus f of a upon g of b minus g of a. So if you are given two functions, you have to apply Cauchy's mean value theorem. So let us understand this using example. So we have to verify Cauchy's mean value theorem for f of x is equals to sin x and g of x is equals to cos x in closed interval 0 to pi by 2. So you can see both the functions are trigonometric function and our interval is first quadrant. So we can say that f and g both are continuous, right, on closed interval 0 to pi by 2. Also we can find f dash of x, which is equals to cos x, and g dash of x will be minus sin x. So both exist on open interval 0 to pi by 2, and even this is not equal to 0. Now we can find the value of c using the formula f dash of c upon g dash of c is equals to f of b minus f of a upon g of b minus g of a. So in place of x, put c in both these derivatives. So we will get cos c upon minus sin c is equals to fb minus fa. So our b is what? Pi by 2. Okay, and a is what? 0. So you can see that sin pi by 2 value is 1 and sin 0 is 0. So we will get 1 upon. Now g of b minus g of a. G of b means pi by 2. So you have to find cos pi by 2. So answer will be what? 0 minus. Now put in place of x 0. So cos 0 is what? 1. So here we have obtained 1 upon minus 1. So finally what we have derived for c is equals to 1. Now we know that the value of c will be what? Pi by 4, which belongs to 0 to pi by 2, clearly, right? So we have verified our Cauchy's mean value theorem. So now let us move on to the next example. So we have to find the value of C using Cauchy's mean value theorem in closed interval 1 to 2 if our f of x is e raised to x and g of x is e raised to minus x. Both the functions are exponential function. So our first condition is verified, that is f of x and g of x both are continuous, right, on closed interval 1 to 2. Now second, you can see that we can find f dash of x, which is equals to e raised to x, and g dash of x will be equals to minus e raised to minus x. So and this is not equal to 0. So both derivative exist, right, on open interval 1 to 2. So now we can find the value of c using the formula f dash of c upon g dash of c is equals to f of b minus f of a upon g of b minus g of a. So let us put the values. You have to replace x by c in both the derivatives. So you will get e raised to c upon minus e raised to minus c is equals to, now our value of a is 1, e is 2. So put in this. So if I put 2, it will be e square minus e upon, I will have what if I put in g, e raised to minus 2 minus e raised to minus 1. So now if I simplify this, what we will get? Minus, take this in the numerator, so it will be minus e raised to 2c is equals to e square minus e. Now I can write this as 1 upon e square minus 1 upon e. Now we will take the LCM. So minus e raised to 2c is equals to e square minus e, and here we will get, if I take the LCM, into we will get e square into e, and in the denominator we will get e minus e square. So finally what remains is minus e raised to 2c is equals to, now I take out minus common, so these two will get cancelled out. So this is equals to minus e cube, right? If I add these powers. So final answer of C will be, comparing this, we will obtain 2c is equals to 3. So the value of C is what? 3 by 2, which belongs to open interval 1 to 2, right? So this is our value of C. So I hope you have understood throughout the session. Thank you for watching.